Again, welcome to Mathematical Structure for Computer Science, CS 113, also known as Discrete Mathematics. In this lectures, we're going to discuss about K-map or Karnaugh Maps. Again, the reason of using K-maps or Karnaugh Maps is the same as simplified Boolean algebra using the Boolean identities. So we may have an expression, and we know that by reducing the expression, we can reduce the number of gates we need for the circuit, for the expression circuit, by using the Boolean identities to simplify the expression. So we also can use the Karnaugh maps to simplify the expression and reduce again, to reduce it. So first we start with what is a logic circuit. Again, a logic circuit is composed of an input, output, functional specification, and also the timing specification. And we can see here, we have our inputs, those are 3 inputs, and we generated 2 outputs based on the functional specification we have. So we may build a circuit or a logic circuit using logic gates to perform different types of function. So it is based on the function and also the timing specifications also. So we have a node. So for example, the input A, B, C here is a node. And also the output, which is Y and Z, is also called nodes. And also we have internal N1, which are also called the nodes. So we can represent our inputs, outputs, or internal components as a node. And also we have the circuit elements. Circuit element can be U1, U2, U3. So it can be, each circuit may have a different elements. And most of the circuit element will consist of logic gates or other specifications, clock, timing. So we have 2 types of logic circuit. The combinational logic, and that's what we are doing now. There's no memory, so it's memoryless, which means the output only can be determined by the input. So whatever we have as our input to the circuit, it determines the function, the circuits, the gates that we have. Whatever task is done, it will give us the output. So the output will be determined only by the current value of input. But with sequential logic, which we are not going to cover in this course, but normally covers in a computer architectural course, is that it also has a memory. So I may have some input, and I may perform some tasks, and I may save that task in a memory. That's in a logic circuit memory. In the future, I may have a different input, but this input cannot determine the output alone. Whatever is in the memory with an active input will determine our output. So here we say the output is determined by previous. So when we say previous, it means we kept it in the memory. There's some data in the memory. So it will determine by the previous and current values of the input. So we may still have the input, the output, the functional and timing specification. So again, a logic circuit consists of an input, output, functional specification, and also timing specification. And we have 2 types of logic circuit, the combinational logic, which doesn't have no memory. So only the output is determined by the input. The input only determines the output. With sequential logic, we have a memory. So the output can be determined not only by the inputs, but also by the previous input that we store in the memory. So here we say the output is determined by previous and current values of inputs. So we should know the difference between the 2. Combinational logic, memoryless. Sequential logic has a memory. So whatever is in the memory with a new active input can determine the output. So here, the rules of combinational composition, we say that every element is combinational. And also every node is either an input or connect to exactly one output. So every node is either an input or connect to exactly one output. And also the circuit contains no cyclic paths. So this is a very good example here. We can see by looking at this circuit, we have two AND gates. Again, we talk about logic gates already. So here we have two AND gates and one OR gate. We can see that we are going straight from left to right. The input comes from the left and the output is our right. So we don't have no cyclic path. For example, I'm here at the end and I'll go back to the beginning again. There's no cycle. And also every node is either an input or connect to exactly one output. So now we start with our main topic, which is the Karnaugh Maps. So the goal of Karnaugh Maps is to reduce the circuit elements or the nodes. So Boolean expression, of course, we saw it can be used to minimize or reduce by combining terms using the Boolean identities. Also, K-maps can be used to minimize a equation, but it's done graphically. And I will always say that the easiest one is K-maps, because here we don't have to know the Boolean identities. Boolean identities is more or less like solving an algebra problem. When you have to know the rules, the formulas of solving it. So example given here, if I have PA plus PA invert, the answer will be P, because by using Boolean algebra, if I have P and PA, P will be common. I'll take P out and I'll have a parenthesis A plus A invert. A plus A invert always will give me 1, because if A is true, then A invert will be false. If A is false, then A inverse will be true. So always true plus false will give me true. So that will be give me 1. So in this case, only P will be left. Now we can also use this for K-map. But here we decided to use an example here. So you can see that in K-map, first most important, we need to get the truth table of the equation. So if I have an equation or an expression that have 3 inputs, A, B, C, then I know the possible combination will be, we discussed this, it will be 8. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, then 1, 1, 1. So it's possible 8 rows. Now, based on the circuit given to us, when we came up the truth table, we found out that we only get 1 that is true when all the 3 inputs are zeros. And we also get 1 when A and B is 0, but C is 1. Now the rest is 0. So whether if we have 0, 1, 0, 0, 1, 1, 1, 0, 0, up to 1, 1, 1, always is 0. So from the expression or the circuit, I was able to come up with the truth table. So now K mapping or Karnaugh maps, the first thing we do is to have our rectangle box. And we have to determine the number of input. Now, if the number of input is only 2, then I may have only square, because we say the possible combination for 2 variables will be 4. But here you can see we have 8 boxes, 1, 2, 3, 4, 1, 2, 3, 4. So the same thing, if the input is 4, 2 to the power 4 is 16. So we're going to have a 16 row, and that will generate 16 boxes here also for us. So it will be 4 by 4. So now, since we have 3 inputs, we say, okay, at the top, we are going to have AB. The 2 inputs will be at the top. Then the down will be only C. So you can see we have 0, 1. But at the top, the first is 0, 0, second 0, 1. Now here we should be careful. K-map, we don't go by 0, 0, 0, 1, 1, 0, 1, 1. Always 1, 1 is the third column. If it's 2 variables here, 1, 1 is the third column. Then 1, 0 will be the last column. So C is only one variable, so we have only 0 and 1. A, B is two variables, so each column we have two variables, 0, 0, 0, 1, 1. So for example, 0, 0 means A and B is 0, 0. 0, 1 means A is 0, but B is 1. 1, 1 means A and B is 1, 1. 1, 0 means A is 1, B is 0. Since C is only one variable, then we get only 0 and 1. Then we come to our truth table. We only get 1 when A, B, C is 0, 0, 0. So we look for A, B, 0, 0. Okay, this is 0, 0. Then we look where C is 0. Okay, this is C 0. So 0, 0, 0, this is 3 zeros now. Will give me 1. Then the next one, we also have A, B to be 0. So I'll be in the first column, A, B, 0, 0. Then this one, C is 1. So it will come to 1. So that's 1 here. So the 1 here means 0, 0, 1, which is 0, 0, 1. Then we say the rest are 0, so put zeros in the rest. Now, if we want to use this to simplify the expression, instead of writing 1, 1, 0, 0 ones, we can write the variables. And if it's 0, means it's A. If it's A inverted, it means it's 0. So you can see the first column and the first row. We have A invert, B invert, C invert, because AB is 0, 0, C is 0, so they are all invert. Then when we go to the first column, second row, we have A invert, B invert, and C, which makes sense because here we have 0, 0, and 1. C is 1. So A invert, B invert. If it's invert, it means the value there is 0. Then we have 0, 1, 0, 1, and 0, which means it will be third row, 0, 1, and 0. 0, 1, and 0 is 0. So 0, 1, and 0 means A is invert because A is 0. B is 1, so it's B. C is 0, so it's C invert. Then here we have 0, 1, 1. 0, 1 means A is invert. Anytime the variable is 0, then we make it invert. If it's 1, we leave it. So 0, 1, 1 means 0 is A. Then B is 1, C is 1, so 1, 1. Then here we have 1, 1, 1, and 0. So we have A, B, C invert. Then we have 1, 1, and the last C is also 1. So A, B, C, everything is 1. So again, this is how we construct the K-map. The next step we're going to learn is how to simplify it. So after we do this finish, we always circle the adjacent squares. So for example, if I have 1 here and I have 1 at the fourth column and the first row, I cannot circle it because we have 0, 0, 0 between. And again, we can also circle the side. We do side circle. So sorry, we can circle the side. But for example, if I have 1, 1 and 0 here as 1, here I can't circle these two ones because there's 0 between them and it's not at the side. But here it's very straightforward. So we see the adjacent circle. So that's what we say. Circle once in adjacent squares. So we see the adjacent squares over there. So we circle 1 and 1 here. So when I circle 1 and 1, Y will be A invert, B invert. And this we can also express it. We saw it in the previous slide. Here we are going to get A invert, B invert, and C invert plus A invert, B invert, and C. So if I have A invert, B invert, C invert plus A invert, B invert, and C, we see that A invert and B invert will come out of common in both terms. So it will come out of the parentheses. Then we have a parenthesis. What is left is C invert plus the second term is only C. But we know C invert and C will give us what? 1. Because if C is 1, C invert is 0. If C is 0, C invert is 1. So 1 plus 0, 0 plus 1, we get 1. So that means we can cancel it out and our final answer will be A invert and B invert. This is if you are doing algebra. Now, with the K-map, we just circle the adjacent. Then we saw that C is what? 0 and 1. So C when 0 and 1 will cancel each other. A and B cannot cancel because it's only A and B. So the answer will be 0, 0. So it will be A invert, B invert. Again, the reason why we cancel the C at one point is 0, at the other point is 1. And we circle both together. So 0 and 1 always will cancel each other out. So now we left with only AB, which is 0, 0. So that will give us A invert, B invert as our answer. So the same thing we have here, if we have all this expression, again, we can simplify it. So now another truth table here. This time, based on expression or the diagram, we find out that 0, 1, 0 is 1, 0, 1, 1 is 1, then all the 3 ones also is 1. So we look at where we get 0, 1, 0. So 0, 1 is the third column and the 0 first row. So we get 1 here. Then the second one, we have 0, 1, 1. So if we have 0, 1, and then the 1 is the second row, so we circle here also. Then we have 1, 1, 1, 1, so that's 1, 1, and the last one also. So we circle the 1, 1 also. Then here you can see that we have 3, so we can take the adjacent 2 and 2 together. So again, you can't take 3, you can take 4. We can take 2, 4. We can circle 2 together. We can circle 4 together. We can circle odd numbers together. We can circle 3. So we circle 2 here, we circle. Then we say, okay, the first 2 we circle, which is on everything on the second column. It means AB is A is what? Invert 0, B is 1. So A invert B. You can see that anytime you circle vertical, C here will cancel because 0 and 1, so they will cancel each other. So that's why we have A invert and B. A invert and B. Then this section, we can see that A is 0 here, A is 1 here. So 0 and 1 will cancel, it left to only 1. So B will be B, but C is invert, so it will be C invert. C is 0, so it's invert. So that's why we get B and C invert. So the final answer will be A invert B plus B C invert. Now, if we are not doing this, it means based on the truth table, our expression will be A invert plus B plus C invert. A invert 0, 1, 0. So it will be A invert B, A times B times C invert. Plus, we go to the second, A invert B and C plus A, B, C. So we have 3 terms. Now, with a Boolean identity, we can reduce it up to where we have it. So where we have it here to be again A invert B plus B C invert. So the K-map definition we have here, we say a complement normally is a variable with a bar over it. So A complement, B complement, C, which normally we represent as zeros. The literal will be a variable or its complement. So we have a variable of A, then its complement, A complement, then B, B complement, C, C complement. Now, imprecant will be the product of literals. So it can be ABC or A, B, or B complement C. It can be any product. So here we have 3 products ABC, 2 products AC, third one BC. Then we also have what we call the prime imprecant. Prime imprecant means imprecant that is corresponding to the largest circle in a K-map. Now, the K-map rule said every one must be circled at least once. So we can see the 2 examples we do, the ones that we circle at least. The second example, we circle once, twice, which is okay. It can be 3 times, it's okay. By a minimum of once. So which means we don't leave any one with that circle. We have to circle all the ones. If one is by itself, then just circle the one by itself. Now we say each circle must span a power of 2. So when you are circle, we should circle 1, then 2, 4, 6, 8, 10, go. Then each circle also must be as large as possible. Now, if I have 4 circles, 1, 1, 1, 1, 4 together, I don't want to circle 2 and circle 2 again. Circle all the 4 together. So that's why we say that each circle must be as large as possible. So I'll have 4 elements in one circle instead of saying 2 and 2. Unless there's a space between the 2 and 2, let's say we have 0 somewhere between 2, then we can't circle all the 4 together. But if all the 4 or 6 or 10, they are all adjacent together, then we circle all together. And also the circle may wrap around edges. So if I have 2 ones in the edge, I can circle them together. So I'll circle them in the edge. Or I have 4 edges, you can circle all. And sometimes we have something we call the I don't care. And I don't care means the answer for the output can be 0 or it can be 1. I don't know the answer, so I can mark there as X also instead of 1. And we normally again circle. If it only help you to minimize the equation, the goal again is to minimize the equation. So here we have a 4 input K map. Again, the expression was given or the diagram was given based on the diagram or the expression. This is what we came up with. So as we said, if we have 4 inputs, then we need 16 boxes, 4 by 4, 16. So now we have AB at the top. C, instead of only C, if we have only 3 inputs, now we have CD. So now we look for the first one. The first one we have is 0010, which gives us 1. So we go to put 1 there. So 0010, 0010. So 1 will be here. Then the first one even give us 0000, give us also 1. So 000, so 1 will be here. And we can see the 1 and 1. Then we go to the third one, we have 0101. So 01 and 01, so we have 1 here. 0101 means A invert B, C invert D. Then we go to another one, 0110. So 0110, so we have our 1. And then you keep going through. So everywhere we have the 1s as our output, we mark it 1 throughout. Let's do last one, 1010. So I'll come to 10, and I need 10 here. So that will be the last value. So when we have this finished, the remaining empty boxes with no 1, we put zeros throughout to finish everything. And that will be the remaining zeros output that we didn't do. Or you can do it also, but again, with time, if you understand, we don't need to do it. We just put the zeros. Then now we're going to circle. So you can see how we circle here. I have 4 together. Oh, I can do all the 4 together. Or if I have 6 together, I should have done 6 together. Then I have 1 by itself, but I took the other 1 and 1, they are adjacent together. So I take the 1 here, so we get 1. Then we have 1 here also by itself. Now we have 1 on all the 4 edges, but some of the edges doesn't get no item, which is there where my pointer is there, the last row and the last column, 4 by 4, the 4th row, 4th column. So the same thing we do, since we have 4 edges, even if I have only 2, again, remember circle is 1 or 2, 4, 6, 8 going. We can't circle 3, we can't circle 5, that's odd. So since I have 2 here, I can just circle the edges. So that's why we can see the edges here is 2. It's for this also, 1 and 2, and then 1 and 2. So it's circle. Now, when you circle more, for example, if I circle 4, my variables will be only 2. If I'm using 4 by 4, here I have 4 variables. So if I circle 4 input together, my term, two terms will cancel each other. We can see here. So for example, here you can see 1110. So that means C is okay, 1 1. But D is 1 and 0, so D will cancel. Then you go there again. I'm doing this too. So I'll go up 0 0 0 1. So the first column, second column. Of that one, see that we have 0 for B and 1 for B. So it left with only A and also C. So I will get the answer to be natural. That's why it's here. And remember, in this case, A was 0, so it's A invert. Here, C was 1, so C. So A invert and C. Again, because we have 4 items. So 1 1 cancel here. At the top 1 1, so cancel 0 and 1 cancel. So 0 and 1 here is D, cancel. And here 0 and 1 here is B, cancel. So you're left with C. But A is invert because the value of A is 0 0. The C is C, the reason why, because it's 1 1. But now when you take only 2 inputs, let's do these 2 inputs, you see that you get 3 variables because only 1 will cancel. The top, nothing will cancel. I have 0 1, so 0 1. So I'll get A, invert, and B. Then here I see 0 and 1. C will cancel. So that means the answer will be D. So it will be A invert, B, and D. And that's what we have here, A invert, B, and D. The last one, we have the edges. So the edges is 4. We have 1, 2, 3, 4. So you look at it. Okay, the edges here, we have 1, 0, and 0, 1. So B is okay. B is invert. 1 and 0 is A, so they will cancel out. So we get B invert here. Then we look from 0, 0, and 1, 0. 0, 0, and 1, 0. So here also the D is 0 and 1, they will cancel. So we get only, 0 and 1 is for C, it will cancel. The last will be 0, 0. So that means we get D invert and B invert. So the answer is B invert and D invert. Again, we are doing the 4 edges. 4 edges. So you look at their variables. In the first column, I'm looking only the edge. So first column, first row, and the last row, because that's the edge. So we know 0, 0 for D, so D invert. C is 0 and 1, so they cancel. Then we look at that's here, we are looking this section, then we come here and look the same thing. 0, 0, 1, 0, so 0 and 1 will cancel. So you're left with only B invert, the last 0 and the 0 here. So that's why the last we have B invert and D invert. So this will be the conclusion of again using the K-map. So the concept of K-mapping is almost the same again as doing the solving Boolean expression using the Boolean identity. The goal is to reduce the equation. And we can see how the boxes cancel 0, 1, 1, 0 cancels some of the variables out. So again, wish you the best and thank you for your time.